graphlib functionality to operate with graph-like structures. Source code lib/graphlib.py. Class graphlib.topological sorter. Graph is equal to none. Provides functionality to topologically sort a graph of hashable nodes. A topological order is a linear ordering of the vertices in a graph such that for every directed edge u to v from vertex u to vertex v, vertex u comes before vertex v in the ordering. For instance, the vertices of the graph may represent tasks to be performed and the edges may represent constraints that one task must be performed before another. In this example, a topological ordering is just a valid sequence for the task. A complete topological ordering is possible if and only if the graph has no directed cycles. That is, if it is a directed cyclic graph. If the optional graph argument is provided, it must be a dictionary representing a directed acyclic graph where the keys are the nodes and the values are iterables of all predecessors of that node in the graph. The nodes that have edges that point to the value in the key. Additional nodes can be added to the graph using the add method. In the general case, the steps required to perform the sorting of a given graph are as follows. Create an instance of the topological sorter with an optional initial graph. Add additional nodes to the graph. Call prepare on the graph. While isActive is true, iterate over the nodes returned by getReady and process them. Call done on each node as it finishes processing. In case just an immediate sorting of the nodes in the graph is required and no parallelism is involved, the convenience method topological sorter.staticOrder can be used directly. Graph is equal to this, ts is equal to topological sorter graph tuple ts.staticOrder. Let's do graphlib. Example 1. Topological sorter. Import graphlib.topological tuple. Tuple t is equal to this and print tuple t. Generate a b c d. The class is designed to easily support parallel processing of the nodes as they become ready. For instance, topological sorter is equal to topological sorter adds node to topological sorter. Topological sorter.prepare while topological sorter.isActive for node in topological sorter.getReady. Worker threads or processes take nodes to work off the task queue. Task queue.put node. When the work for a node is done, workers put the node in finalized task queue so we can get more nodes to work. The definition of isActive guarantees that at this point at least one node has been placed on task queue that has not yet been passed to done. So this blocking get must eventually succeed. After calling done, we loop back to call getReady again. So put newly freed nodes on task queue as soon as logically possible. Node finalize task queue.get topological sorter.done node. Add node asterisk predecessors. Add a new node and its predecessors to the graph. Both the node and all elements in predecessors must be hashable. If called multiple times with the same node argument, the set of dependencies will be the union of all dependencies passed in. It is possible to add a node with no dependencies, predecessors is not provided, or to provide a dependency twice. If a node that has not been provided before is included among predecessors, it will be automatically added to the graph with no predecessors of its own. Raises value error if called after prepare. Mark the graph as finished and check for cycles in the graph. If any cycle is detected, cycle error will be raised. But get ready can still be used to obtain as many nodes as possible until cycle block more progress. After a call to this function, the graph cannot be modified and therefore no more nodes can be added using add. Is active returns true if more progress can be made and false otherwise. Progress can be made if cycle do not block the resolution and either there are still nodes ready that haven't yet been returned by topological sorter then get ready, or the number of nodes marked topological sorter to done is less than the number that have been returned by the topological sorter to get ready. The bool method of this class differs to this function. So instead of if ts dot is active, it is possible to simply do if ts raises value error if called without calling prepare previously. Done at pointer nodes marks a set of nodes returned by topological sorter dot get ready as processed, unblocking any successor of each node in nodes for being returned in the future by a call to topological sorter dot get ready. Raises value error if any node in nodes has already been marked as processed by a previous call to this method, or if a node was not added to the graph by using topological sorter.add if called without calling prepare, or if node has not yet been returned by get ready returns a tuple with all the nodes that are ready. Initially it returns all nodes with no predecessors, and once those are marked as processed by calling topological sorter.done, further calls will return all new nodes that have all their predecessors already processed. Once no more progress can be made, empty tuples are returned. Raises value ever if called without calling prepare previously. Static order returns an iterator object which will iterate over nodes in a topological order. When using this method, prepare and done should not be called. This method is equivalent to diff static order self.prepare while self.isActive node group is equal to self.getReady yield from node group self.done pointer node group. The particular order that is returned may depend on the specific order in which the items were inserted in the graph. For example, TS topological sorter ts.add 3 to 1 ts.add 1 0 print pointer ts.static order 2013 ts2 topological sorter ts2.add 1 0 ts2.add 3 to 1 0 to 1 3. This is due to the fact that 0 and 2 are in the same level in the graph. They would have been returned in the same call to get ready, and the order between them is determined by the order of insertion. If any cycle is detected, cycle error will be raised. Exceptions. The graphlib module defines the following exception classes. Exception graphlib or cycle error. Subclass of value error raised by topological sorter.prepare if cycle exists in the working graph. If multiple cycle exist, only one undefined choice among them will be reported and included in the exception. The detected cycle can be accessed via the second element in the args attribute of the exception instance and consists in a list of nodes such that each node is in the graph an immediate predecessor of the next node in the list. In the reported list, the first and the last node will be the same to make it clear that it is a cycle.